Our Milky Way galaxy is a vast and awe-inspiring place. It is a swirling city of stars, gas, and dust. Imagine a celestial disk, a cosmic pizza dough stretched thin across the cosmos. That is the Milky Way, our home galaxy. It spans a staggering 100,000 light years in diameter. From our vantage point, we see the Milky Way as a band of light stretching across the night sky. It is humbling to realize our sun is just one of hundreds of billions of stars. New stars are born, while others die in spectacular supernova explosions. The Milky Way is classified as a barred spiral galaxy. This means that it has a central bar-shaped structure composed of stars, gas, and dust. This bar is thought to play a role in channeling gas and dust towards the galactic center. This process fuels star formation and influences the overall structure of the galaxy. Emanating from the ends of this central bar are multiple spiral arms. These arms are regions of higher density within the galactic disk. They are home to a greater concentration of stars, gas, and dust. The spiral arms are not static features. They are constantly rotating and evolving. Our galaxy has four major spiral arms: the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the Norma arm. There are also several smaller arms and spurs, including the Orion arm. These arms are not solid structures. They are more like waves of density moving through the galactic disk. At the center of the Milky Way lies a supermassive black hole where gravity is so strong that nothing, not even light, can escape. Known as Sagittarius A, it is over 4 million times the mass of our Sun. The central bulge of the Milky Way surrounds this black hole. This bulge is densely packed with stars, gas, and dust. Astronomers observe powerful jets of radiation and particles from the black hole. Our solar system resides in a relatively quiet backwater of the Milky Way within the Orion arm. We are situated about 2/3 of the way out from the galactic center. This location, while seemingly insignificant, is actually quite advantageous for life as we know it. Being situated within a spiral arm, though not directly in its densest regions, provides us with a balance. We have access to the raw materials needed for star and planet formation, but we are also shielded from the intense radiation and gravitational forces found closer to the galactic center. Our solar system is constantly in motion. We are orbiting the galactic center at a speed of about 515,000 miles per hour, 828,000 kilometers per hour. Even at this incredible speed, it takes our solar system approximately 230 million years to complete one orbit around the Milky Way. Section 5. A galactic carousel. The Milky Way, like most galaxies, is in constant rotation. However, it doesn't rotate like a solid disk. Instead, stars and gas clouds closer to the center orbit faster than those farther out. This phenomenon, known as differential rotation, is a key characteristic of spiral galaxies. Imagine a giant cosmic carousel with horses placed at different distances from the center. The horses closest to the center complete their rotations faster than those farther out. Similarly, stars and gas clouds in the Milky Way's inner regions complete their orbits around the galactic center much faster than those in the outer regions. This differential rotation has important implications for the structure and evolution of the galaxy. It helps to maintain the spiral arm structure and influences the distribution of stars, gas, and dust within the galactic disk. It also plays a role in the formation of new stars. Section 6. Stellar nurseries. Scattered throughout the Milky Way's spiral arms are vast clouds of gas and dust known as nebulae. These nebulae serve as stellar nurseries, the birthplaces of stars. Within these cosmic clouds, gravity gathers and compresses the gas and dust, causing them to collapse and heat up. As the temperature and pressure at the core of a collapsing cloud reach a critical point, nuclear fusion ignites. Hydrogen atoms fuse to form helium, releasing an enormous amount of energy. A star is born. Some of these nebulae are so large and bright that they can be seen from Earth with the naked eye. The Orion Nebula, located in the constellation Orion, is a prime example of a stellar nursery. It is one of the closest and most easily observed star-forming regions in the night sky. By studying these stellar nurseries, astronomers gain insights into the processes that govern the birth and evolution of stars. Section 7. A galaxy of stars. The Milky Way is home to a staggering diversity of stars, each with its own unique story to tell. Stars come in a wide range of sizes, temperatures, colors, and luminosities. Our Sun, a medium-sized yellow star, is just one example of the stellar variety found within our galaxy. Some stars are much larger and more massive than our Sun, burning brightly and living relatively short lives. These massive stars often end their lives in spectacular supernova explosions, seeding the interstellar medium with heavy elements. Other stars are much smaller and cooler than our Sun, living for billions of years. Red dwarfs, the most common type of star in the Milky Way, are much smaller and cooler than our Sun. They burn their fuel slowly and can live for trillions of years. Giant stars, as their name suggests, are much larger than our Sun and can be hundreds of times more luminous. Section 8. The Milky Way's dark secret. Surrounding the visible disk of the Milky Way is a vast and mysterious halo of dark matter. Dark matter is an invisible form of matter that does not interact with light. Its presence is inferred through its gravitational effects on visible matter. Dark matter makes up about 85% of the Milky Way's total mass. Stars, gas, and dust account for a small fraction of the galaxy's mass. The nature of dark matter remains one of the biggest mysteries in astrophysics. Section 9. Galactic Encounters. The Milky Way is not alone in the vast expanse of the universe. It is a member of a group of galaxies known as the Local Group. This group contains over 50 galaxies, including our nearest large neighbor, the Andromeda Galaxy. The galaxies within the Local Group are gravitationally bound to one another, meaning that they are constantly interacting and influencing each other's evolution. In fact, astronomers predict that the Milky Way and Andromeda galaxies are on a collision course. billions of years from now, these two spiral galaxies will merge in a spectacular cosmic dance. This merger, while not a catastrophic event for individual stars, will dramatically reshape the structure of both galaxies, resulting in a new elliptical galaxy.